Dear students, welcome to Nivi's Patashala. In this video, we will be studying about deterministic finite automata. Let us consider an example where we have to construct a DFA to accept strings of A's and B's ending with A. So the first step we have to do is analyze the given problem. So the accepting strings are A and n number of A's. So whatever the string we have, it has to end with A. Here in this string we have n number of B's ending with A. So any string that is ending with A is supposed to be accepted, and any string that does not end with A is supposed to be rejected. So here we have some rejecting strings. If I have BA, it is supposed to be rejected. If I have AA and then it ends with B, the string is supposed to be rejected. So we have to construct a DFA in the form where ending with AA is accepted and the string which does not end with AA is supposed to be rejected. This example can also be used as a reference for strings of zeros and ones ending with 1 or strings of zeros and ones ending with 0. So the first step we have to do is identify the minimum string. So from the given question we can identify that the minimum string is A. And the input alphabets, that is the symbols we have here, is A and B. So the skeleton for the minimum string, here we have Q0, Q1 and Q2 because the length of the string is 2 and the minimum states I will be requiring is n plus 1 state, that is 2 plus 1, that is 3 states. So therefore I have Q0, Q1 and Q2 where A is being accepted, that is it is in the final state. So writing down the transitions for the minimum string, I have Q0 on input A goes to Q1 and Q1 on input A goes to Q2. So this is the transition table where I have in the first column I have all the states Q0, Q1 and Q2, where Q0 is represented with a small arrow to show that it is a start state and Q2 is the final state. And in the first row I have all the input symbols, that is A and B. So from the diagram and from the transitions we can know that Q0 on input A goes to Q1 and Q1 on input A goes to Q2. The rest of the cells are left empty. Now let us complete the construction of DFA and represent it in the mathematical format. We have got the skeleton diagram for the minimum string AA. Now if my string is n number of A's, which is supposed to be accepted by the DFA, I can loop n number of A's to Q2. So if my string has n number of A's, it comes from Q0 to Q1, then from Q1 to Q2, and n number of A's gets looped in Q2, which is supposed to be a accepting string. Now if my string starts with B followed by 2 A's, which is supposed to be accepted by the DFA, I can loop B to Q0. So B, A is being accepted by the DFA. If I have n number of B's followed by A's ending with 2 A's, AA, this string is also supposed to be accepted by the DFA. So n number of B's gets looped in Q0 and AA is reaching the final state. Now if my string is BA, this is also supposed to be accepting string. So if we loop B, A and again if we loop B to Q1, if we loop B to Q1, what happens if I get a string which is A. That is A, if B gets looped in Q1 and A, this is supposed to be rejected whereas it is getting accepted. If I have A, B, A, this is also supposed to be rejected, but it has been accepted. Therefore, we cannot loop B in Q1. So instead, I will give back B to Q0. So if I have A, B, A, it is in a non-final state. So A, B, A is in Q1, which is a non-final state. Therefore, the string is being rejected. If I have A, B followed by n number of B's, it gets looped in Q0 and A is being accepted. So rather than looping B to Q1, which will not be the correct DFA construction, we can give back B to Q0. Now if I have A and then followed by n number of B's, so that time I can give back B to Q0. Again A will reach the final state. So Q0 to Q1 moves from A, Q1 to Q2 moves from A, and if I have n number of B's, I am giving it back to Q0. They get looped n number of times and A reaches the final state. Let us make a note in the transition table at the same time, and these are the transitions. We can write them down either from the diagram or from the table. That is, on input Q0 on input A goes to Q1. That is, Q0 on input A goes to Q1. Q0 on input B is in Q0 itself. So Q0 on input B is in Q0 itself. The same way the transitions can be done for all the states. Q2 on input B is going to Q0. That is, Q2 on input B is going to Q0. The mathematical representation, we have Q, which represents all the states, that is Q0, Q1 and Q2. The alphabet, that is the input symbols, are A and B, and the start state is Q0 and the final state is Q2. Let us look at another example here. Construct a DFA to accept strings of zeros and ones ending with 1, 0, 1. So let us analyze the accepting and rejecting strings. The minimum string is 1, 0, 1. So 1, 0, 1 should be accepted by the DFA. N number of zeros ending with 1, 0, 1 should be accepted by the DFA. N number of ones ending with 1, 0, 1 or any combinations of ones and zeros that end with 1, 0, 1 should be accepted by the DFA. The rejecting strings are if I have only 0 or if I have n number of zeros or if I have only 1 or n number of ones, or if my string is having 0, 1 or 1, 0, or if my strings are not ending with 1, 0, 1. If it ends with 0, 0, 1 or if it ends with 1, 1, 0, or here I have 1, 0, 1 but it is ending with another 1. So it is 1, 0, 1, 1. Therefore, it is not ending with 1, 0, 1. So the strings that do not end with 1, 0, 1 are supposed to be rejected by the DFA. So the first step is to identify the minimum string. We know that it is 1, 0, 1. And to identify the alphabets, that is nothing but the input symbols, that is 0 and 1. The skeleton for 101 for the minimum string is here. So we can know that the length of the string is 3 and I will be requiring n plus 1 states. So it is 3 plus 1. So I have 4 states, Q0, Q1, Q2 and Q3, where Q3 is the final state. So here we can see 1, 0, 1 is being accepted. These are the transitions we have. Q0 on input 1 goes to Q1, Q1 on input 0 goes to Q2 and Q2 on input 1 goes to Q3. This is the transition table. Q0 on 1 goes to Q1, Q1 on 0 goes to Q2 and Q2 on 1 goes to Q3. The rest of the cells are left empty as we are supposed to still construct the complete DFA and understand what are the transitions. So now let us complete the construction of DFA and represent it in the mathematical format. We know this is the skeleton for 101 which is being accepted by the DFA. Now, if I have n number of zeros ending with 101, the string should be accepted. So, I am looping n number of zeros in Q0. So, if I have n number of zeros ending with 101, the string has been accepted. If I have n number of ones ending with 101, I am looping n number of ones in Q1. So, the first 1 moves from Q0 to Q1 and then the rest of the ones gets looped in Q1, where again we have ending with 101. Therefore, it is in the final state. Where in the table Q1 with input 1 is in Q1 itself. Next, I have 101 with n number of ones in between ending with 101. So, I have 101 which is in the final state. After reaching the final state, I again have n number of ones. So, what I am doing from Q3, I am giving those ones to Q1. If you are wondering to loop 1 here in Q3, what happens when I loop 1 in Q3? That time if I have 1011, this string is supposed to be rejected. But if I loop 1 here in Q3 in the final state, the string is getting accepted. If I have 101 and n number of ones, the string is supposed to get rejected. So, if I loop 1 in Q3, the DFA construction is not correct. So, instead I am giving 1 to Q1. So, 101 and 1 goes back to Q1, n number of ones get looped in Q1, again ending with 101. Now, if I have 10101, so I have 101, and if I have 01, so I am giving 10, n number of zeros I am giving to Q0, and I am looping n number of zeros in Q0 ending with 101. Now here we have, if I have Q3 on input 0. So if I have 101 and then if I have 0, I am giving it to Q2, which means if I have 10101 is supposed to be accepted. 10101 is supposed to be accepted. So from Q3 I am giving 0 to Q2 and again 1 gets accepted. Now if I have n number of zeros in between, 101, n number of zeros and again ending with 101. So what happens? 101. The first 0 goes from Q3 to Q2 and again the second 0 goes from Q2 to Q0, and then n number of zeros gets looped in Q0 and then 101 goes to the final state. Now if I loop 0 in Q2, if I try to loop zeros in Q2, what happens? If I have a string which is 10001 is supposed to get rejected. But if I loop zeros in Q2, the string gets accepted. That is, if I have 1 followed by 0 with n number of zeros ending with 1 should get rejected, but the DFA is accepting. Therefore, I cannot loop zeros to Q2. The same way, if I have 1, 0, n number of zeros, it comes back to Q0, gets looped here, and again it has to end with 1, 0, 1. Now let us complete the table here and write down the transitions. So from Q0 on input 0, it is in Q0 itself. We can either write the transitions from the table or from the diagram. Q0 on input 1 is going to Q1. Q0 on input 1 is going to Q1. The same way, Q3 on input 0 is going to Q2. So Q3 on input 0 is going to Q2. Q3 on input 1 is going to Q1. So Q3 on input 1 is going to Q1. We can check whether any rejecting string is being accepted. If any rejecting string is being accepted by the DFA, then the construction is not correct. The mathematical representation, here we have Q representing all the states. I have 4 states, Q0, Q1, Q2, Q3, and the alphabet, that is the input symbols, are 0 and 1. Q0 is the start state, and we have only one final state, that is F, which is the final state, and these are the transitions we have in the mathematical representation format. Let us take another example here. Construct a DFA to accept strings of zeros and ones ending with 1, 1, 0. This can also be used as a reference for strings of A's and B's ending with A, A, B or B, B, A with respect to zeros and ones. So the first step is to analyze the given question. We have strings of zeros and ones ending with 1, 1, 0. So the minimum string is 1, 1, 0. And any string ending with 110, that is n number of zeros ending with 110 should be accepted, n number of ones ending with 110 should be accepted, n number of ones and zeros ending with 110 should be accepted. What are the rejecting strings? If I have only 0, or if I have 0, 0, or if I have n number of zeros, or if I have only 1 or n number of ones, or any string that does not end with 110. Any string that does not end with 110 should be rejected by the DFA. So the first step is to identify the minimum string. The minimum string is 110, and the input alphabets that we have with the question is zeros and ones. So the input is 0 and 1. Now the skeleton for the minimum string 110 is given here. We have 4 states, that is the length of the string is 3. I will be requiring n plus 1 states, so that is nothing but 3 plus 1 states. So I have Q0, Q1, Q2 and Q3, where 110 is being accepted, and the transitions are here. Q0 on input 1 is going to Q1, Q1 on input 1 is going to Q2, and Q2 on input 0 is going to Q3. This is the table which we have filled. Q0 on 1 going to Q1, Q1 on 1 going to Q2, Q2 on 0 going to Q3, and the rest of the cells are still to be identified. Always remember to mark the start state and the final state. Now let us complete constructing the DFA and giving its mathematical representation. Here we have the skeleton diagram for 110, that is the minimum string which is being accepted by the DFA. Now if my string has n number of zeros ending with 110, it has to be accepted. So I am looping n number of zeros in Q0 and it is ending with 110. So let us write it in the table. Q0 on input 0 is going to Q0. Now I have n number of ones ending with 110. Now if I loop n number of ones in Q1, then we have a confusion state here. So if I have 1110, what happens? The first one comes from Q0 to Q1 and then n number of ones ending with 110. What happens? This state is in a confusion state whether it has to loop that one or whether it has to give it to Q2. So I cannot loop 1 in Q1. Instead, I will loop 1 in Q2. Therefore, there is no confusion state here. So 1, 1 and n number of ones and 0 is reaching the final state. Next, I have 1 n number of zeros and then again 1 ending with 110. Now, if I loop n number of zeros here, what will happen if I have a string 1010 which is supposed to be rejected gets accepted, that is 1010 is getting accepted by the DFA which is supposed to be rejected. Therefore, I cannot loop zeros in Q1. So instead I can give n number of zeros to Q0. So if I have 1 n number of zeros, it gets looped in Q0 and ending with 1 1 or n number of ones ending with 0 is being accepted. Next we have 1 1 0 1 1 0 which is supposed to be accepted. So if I have 1 1 0 and if I give 1 from Q3 to Q2, if I give 1 from Q3 to Q2, what happens if I have a string that is 1 0 1 or if I have 1 1 0 ending with 1 0, it is supposed to be rejected. A string ending with 0 1 0 is supposed to be rejected. What happens here? The string is getting accepted. If I have 1 1 1 0 1 0, it should get rejected, but if I give 1 here, it is getting accepted. Therefore, I cannot give 1 here. Instead, I can give 1 from Q3 to Q1. So what happens? 1 1 0 1 1 0 is getting accepted. If I have 1 1 0 1 0, it is remaining in the non-final state, which means the string is not being accepted. Now if I have 1 1 0 followed by few zeros again ending with 1 1 0, the string should be accepted. So from Q3 I have reached Q3, that is 1 1 0. I am in the final state. If I have n number of zeros ending with 1 1 0, so I am giving those n number of zeros to Q0. I cannot loop zeros in Q3 because 1 1 0 0 n number of zeros will get accepted by the DFA, which is not correct. So I am giving zeros back to Q0 because Q2 is a state looping ones and Q1 is a state accepting ones and Q0 is only the state which is looping zeros. So if I give back 0 here, 1 1 0 will reach the final state. Let us fill the transition table. Now let us write down the transitions. We can use the transition table or the diagram to write down the transitions. Q0 on input 0 goes to Q0, Q1 on input 0 goes to Q0, Q1 on input 1 goes to Q2. So we can finish the transitions and give the mathematical representation where Q is all the states, that is Q0, Q1, Q2 and Q3. The input, that is the alphabet, is 0, 1 and the start state is Q0 and the final state is Q3 and the transitions are here. Thank you for watching and don't forget to like, share and subscribe.